One of life's greatest illusions is the illusion of permanence. We think the world around us has always been this way, and always will be. That tomorrow will arrive just as today arrived. That the laws by which life exists are immutable and eternal. We wake up in the morning, and the sun is still there, the sky is still there, and the ground beneath our feet is solid. We make plans for years to come, never allowing ourselves to consider that the very foundation of our existence could vanish in an instant. 66 million years ago, dinosaurs lived under precisely this illusion. Although, of course, they didn't realize it. They simply lived. Their uninterrupted dominance of the planet had already lasted 165 million years, and there was no indication that this would ever change. To put that number into perspective, consider this. The entire span of human existence, from the first stone tools to spaceships, fits into about 3 million years. Dinosaurs ruled the planet 55 times longer. The world was warm and fertile. The average temperature on the planet was significantly higher than today. Polar ice caps did not exist. Lush forests covered most of the land, with an incredible diversity of trees, flowers, ferns, and trillions of small creatures. Dinosaurs were everywhere, diversifying into hundreds of species of all shapes and sizes. Titanosaurs, vast and gentle giants weighing tens of tons, shared the planet with renowned predators like the Tyrannosaurus, whose jaws could crush bones like dry twigs. Pectinodon hunted in the undergrowth, relying on its enormous eyes and keen intelligence. Edmontosaurus roamed the coasts and swamps in vast herds. Pterosaurs soared through the skies, some with wingspans of over 10 meters. Mosasaurs and plesiosaurs reigned in the oceans. It was an ancient paradise, a world of abundance, brimming with life. A world in which every ecological niche was occupied, every corner of land and sea teeming with creatures honed by millions of years of evolution. 66 million years ago, perhaps on a Tuesday afternoon, life was exactly the same as it had been the day before, or 1,000 years ago, or 1,000,000 years ago. All was perfect for our feathered dinosaur friends, until one tiny detail in the sky changed. If any of the dinosaurs had been stargazers, they might have noticed the emergence of a new star one night, a tiny dot that, over the course of many weeks, slowly grew larger and brighter. At first, it was indistinguishable from thousands of other stars. Then it became more noticeable. Then more noticeable still. Until, one fateful evening, it resembled a small second moon in the night sky. And then, it disappeared from view, diving into the Earth's shadow. For a few more hours, the illusion of permanence held. The world looked as it always had. Forests rustled, rivers flowed, predators hunted, herbivores grazed. Everything was as usual. Until it wasn't. That morning, the object suddenly reappeared. Now, almost as large as the sun in the sky, it grew larger with each passing moment, moving inexorably toward the coast near the Yucatan Peninsula. At that moment, shallow tropical seas and dense coastal forests stretched across what is now Mexico. Stegoceratops grazed in fern meadows, tyrannosaurs prowled among the trees, pterosaurs glided over the waves scanning for fish. None of them looked up. The asteroid needed only 2 seconds to pass through the thin layer between space and the Earth's surface. It entered the atmosphere at nearly 60 times the speed of sound. At that speed, the air in front of the asteroid doesn't have time to part. It compresses into a superheated shock wave, which is hot enough to ignite everything in its path. Let's freeze time. At this very moment, before us stands an unnamed asteroid, poised to wreak havoc on entire species. It surpasses Mount Everest in size, with a diameter of between 10 and 15 kilometers. It extends from the ocean surface high into the atmosphere, higher than passenger planes will fly millions of years from now. In that moment, the world was one thing. In a split second, it will be fundamentally different. We know this happened because the evidence is written in the rocks themselves. In 1980, father and son geologist Walter Alvarez and Nobel Prize-winning physicist Luis Alvarez discovered a thin layer of clay, 66 million years old, in rocks around the world. This layer contained an anomalously high concentration of iridium, an element rare on Earth but common in asteroids. Later, in 1991, the crater itself was discovered, buried beneath the Chicxulub deposits on the Yucatan Peninsula, 180 kilometers in diameter. The crater is so enormous that it is impossible to see from the surface. Its outlines were revealed only through gravity measurements and drilling. This is what happened that day. An asteroid slams into a shallow ocean and the bedrock beneath. The energy of billions of nuclear bombs is released instantly. Try to imagine the scale. The most powerful nuclear bomb ever tested by humanity, Tsar Bomba, was capable of destroying a large city. The energy of the asteroid's impact is equivalent to 10 billion such bombs detonated at a single point in an instant. A flash of light illuminates the sky as an eerie, blindingly white sphere expands over the Gulf of Mexico. This sphere expands at a speed that is incomprehensible. The bedrock melts, turning into superheated plasma with temperatures of tens of thousands of degrees. Thermal radiation from the explosion spreads at the speed of light and instantly incinerates all life within a radius of approximately 1,500 kilometers. Every tree, every bush, every creature in this zone literally ceases to exist in a split second. They do not burn, they do not char, they simply evaporate. Millions of year-old forests are transformed into molten gas faster than a dinosaur could blink. Meanwhile, the energy of the impact crushes the Earth's crust with such force that it loses all strength and flows away from the impact site like liquid. Rocks, which we usually consider the embodiment of solidity and indestructibility, behave like water under this monstrous pressure. A crater is formed 25 kilometers deep and 100 kilometers wide. By comparison, the deepest canyon on Earth, the Yarlung Sangpo Canyon in Tibet, is about 6 kilometers deep. The asteroid impact crater is 4 times deeper. The ocean is thrown back hundreds of kilometers, like water in a puddle when a child jumps into it. The seabed is exposed over an area comparable to the territory of an entire country. As the Earth's crust springs back, molten and fluid rock forms a temporary mountain rising 10 kilometers into the sky. A staggering amount of material is ejected into the upper atmosphere, or even into outer space. The ejected material is estimated to be 60 times the mass of the asteroid itself. Imagine a rock the size of Mount Everest slamming into the planet and blasting out 60 times its own volume. This material, hot rock fragments, molten glass, vaporized rock, flies in all directions. Some of it escapes the atmosphere and enters low Earth orbit. Some reaches the Moon. Some even reaches Mars. But most will return. And when it returns, the next act of the nightmare will begin. The force of the impact is felt everywhere on Earth for several minutes. A magnitude 11 earthquake shakes the planet. To understand what this means, remember that the most powerful earthquake in modern history, which struck Chile in 1960, had a magnitude of 9.5. The magnitude scale is logarithmic, meaning that a magnitude 11 earthquake is approximately 1,000 times more powerful than the Chilean one. This is likely the most powerful earthquake ever felt by any living being in the billions of years of Earth's history. It is so monstrously strong that in India, on the opposite side of the planet, it could shake giant lava fields and trigger volcanic eruptions that would last for 30,000 years and cover half the Indian subcontinent in lava. These eruptions, known as the Deccan Traps, would alone be the largest volcanic catastrophe in the history of life on Earth. But compared to what was happening off the Yucatan, they were merely a side effect. Even on the side of the Earth diametrically opposite the impact site, the ground shifted several meters. Not a single living creature on the planet would have slept through that day. A gigantic explosion slams into the atmosphere with unprecedented fury, generating a shock wave that, near the impact site, reaches speeds of over 1,000 kilometers per hour. This is comparable to hyperhurricanes on gas giants like Neptune. The strongest hurricanes known to modern Earth carry winds of around 300 kilometers per hour. The shock wave from the asteroid was 3 times more powerful. In Central America, literally everything, soil, vegetation, animals, is torn to pieces and hurled thousands of kilometers. The land for hundreds of kilometers around the crater is transformed into a scorched desert, cleared of all life within minutes. Not a single forest, not a single hill, not a single river remains. The landscape ceases to exist. The dinosaurs that inhabited what is now Mexico and the southern United States were killed in the first minutes. They didn't even have time to understand what had happened. Now the displaced oceans are returning. When the temporary mountain at the impact site collapses, a tsunami ring up to 1 kilometer high spreads out in all directions. 1 kilometer. Try to comprehend that number. The tallest building ever built by humanity, the Burj Khalifa, is 828 meters. These waves were higher. They were taller than any skyscraper humans will ever build. A kilometer-high wall of water rushing across the ocean at the speed of a jet, carrying seafloor debris, dead sea creatures, and entire layers of sediment. When these waves crash onto the coasts of the surrounding continents, they inundate thousands of kilometers of coastline. Everything on the coasts of North and South America disappears beneath the water. The interiors of the continents, hundreds of kilometers from the ocean, are submerged. In geological layers from this period, scientists are finding marine sediments in places hundreds of kilometers from the modern coast, silent evidence of how far the water had reached. 15 hours later, some waves refracted around South America still rise 100 meters above the ocean surface. The tsunami caused by the asteroid swept across all the planet's oceans. No coastline was safe. But we still haven't covered the scariest part. A huge portion of the debris ejected into space will orbit the Earth for thousands of years. Some of it will hit the Moon, or even reach Mars. But the bulk will return to Earth. Imagine this: millions of tons of red-hot rock fragments ejected from the atmosphere are now falling back from all directions simultaneously. Each fragment enters the atmosphere at cosmic speeds and glows white-hot, like a meteor. But this isn't a single meteor. These are billions of meteors falling simultaneously. And this is where what many paleontologists believe is the main cause of mass extinctions begins. When objects fall through the atmosphere at such speeds, they heat up to hundreds of degrees. And this happens to millions of tons of material at once, all over the planet's surface. The atmosphere rapidly heats up to insane temperatures. Scientists are still debating exactly how hot the air became and how long this thermal shock lasted. There are 2 main theories. According to the first, the air heated up to several hundred degrees over the course of several minutes. According to the second, the temperature jumped to several thousand degrees, but only for a minute. In either case, the atmosphere became as hot as the inside of an industrial furnace. Any creature that didn't manage to burrow underground or hide in a cave was doomed. Feathers, skins, leaves, everything exposed to the air burst into flames and charred. The heat, coupled with a rain of hot debris, ignited the forest floor and ignited wildfires as the Earth rotated beneath the blazing plume. The planet literally spun beneath a rain of fire. Every patch of land, passing beneath the burning shroud of the upper atmosphere, received its share of hot debris, and new fires erupted in each patch. Within hours, massive fires likely raged across the entire planet simultaneously. These were not the ordinary forest fires we know today. These were continental-scale firestorms, fueled by millions of square kilometers of dry forest that had accumulated combustible material for millions of years. Some of these fires could last for months, transforming the Earth into a terrifying, incandescent version of itself. Forests that had covered continents for millions of years were reduced to ash. The air filled with soot and smoke. The sky turned crimson and black. The geological record of this period contains a thin layer of soot, found on every continent on the planet. This layer is all that remains of the Cretaceous forests. By the end of the first day after the impact, millions of dinosaurs were already dead. But the worst was yet to come. A gigantic plume of vaporized material reaches the upper atmosphere and spreads around the globe. Together with soot from the burning planet and aerosols formed on impact, it plunges the Earth into profound darkness. This wasn't just cloudy weather. This was a darkness so thick you couldn't even see your own paw in it. Sunlight no longer reaches the surface. The only source of illumination comes from raging fires, illuminating the landscape with an eerie orange glow. Imagine standing in the middle of what was yesterday a tropical forest. Burning tree trunks surround you. Overhead, impenetrable blackness, through which not a single ray of sunlight penetrates. The air is filled with ash and acrid smoke. The temperature drops with each passing hour. Plants that survived the firestorms are now deprived of sunlight. Global photosynthesis effectively ceases. Without photosynthesis, plants cannot produce oxygen and organic matter, meaning the entire food chain on land begins to collapse from the bottom up. Within a few days, surface temperatures plummet by 25 degrees. The world, which only yesterday was a warm, tropical paradise, is plunged into cold and darkness. This is called a shock winter, and it will last not days or weeks, but decades. The oceans were hit particularly hard. The lack of sunlight destroyed over 90% of the plankton that forms the basis of the marine food chain. Plankton are more than just tiny organisms floating in the water. They are the foundation on which the entire marine ecosystem rests. Without plankton, the entire food chain collapses. Small fish are deprived of food and die. Larger predators follow. Giant marine reptiles, mosasaurs and plesiosaurs, that dominated the oceans for millions of years, are dying out because they no longer have anything to eat. Ammonites, which had survived hundreds of millions of years and survived numerous previous catastrophes, including the Great Permian Extinction, are gone forever. In addition to darkness, the oceans faced another problem. Carbon dioxide, released in huge quantities by the impact, began to dissolve in the seawater, increasing its acidity. The acidic water corroded the shells and skeletons of marine organisms, making survival even more difficult. Oceans that had recently teemed with life were transformed into quiet, empty expanses of water. The biosphere in which the survivors find themselves resembles an alien landscape. Ash, debris, and the charred remains of once lush and flourishing life cover the ground. The sky is dark and cold. Fresh food is virtually non-existent, but fungi thrive. Fungi become one of the few organisms with food in a world of dead organic matter. They feed on decaying wood, animal carcasses, rotting tree roots, all that remains of the former world. Paleontologists find a so-called fungal peak in geological layers from this period. A sharp increase in the number of fungal spores, indicating that, for a time, fungi became the dominant life form on land. A world where powerful reptiles weighing tens of tons once reigned is now temporarily dominated by microscopic organisms and mold. For months and years, the planet remains a hostile and deadly place. A sudden global winter lasts for decades. Even when the dust and soot finally begin to settle and sunlight timidly returns, the world faces the opposite problem. All the carbon dioxide released by the impact and the fires remains in the atmosphere, and after decades of cold, a period of intense greenhouse warming sets in. Temperatures soar above normal, and surviving organisms that had barely adapted to the cold are now forced to survive in the heat. This double whammy, first the cold, then the heat, decimates many of those who survived the initial catastrophe. At least 75% of all species on Earth simply vanish from existence. 3/4 of the entire diversity of life, built over millions of years, is erased in a geological instant. Among the dead, all non-avian dinosaurs, all pterosaurs, all marine reptiles, all ammonites, most shark species, most mollusks. Survivors included some small birds, small mammals, crocodiles, turtles, snakes, frogs, and some insects and freshwater fish. The general rule was simple and merciless. The larger the creature and the higher it stood on the food chain, the less likely it was to survive. And so, as this interminably long first day draws to a close, the world suddenly becomes different. The constancy that lasted 165 million years no longer exists. The age of dinosaurs is over. Just like that. Simple. Without warning, without a chance to prepare, without a chance for salvation for those who ruled this planet longer than any other group of large animals in Earth's history. One random chunk of rock and ice, hurtling through space for millions of years, crossed Earth's orbit at the wrong moment, and an entire era was over. It's worth considering the magnitude of this chance. If the asteroid had arrived 10 minutes earlier, or 10 minutes later, it would have crashed into the deep ocean, and the consequences would have been very different. If it had passed slightly to the left or slightly to the right, it would have missed Earth entirely, and dinosaurs might still be roaming the planet today. The entire history of life on Earth, including our own existence, depended on whether a rock from space arrived a few minutes earlier or later. But from the ashes of the old world, survivors gradually emerged. They were small. They were inconspicuous. They were the ones no one paid attention to during the 165 million years that dinosaurs reigned supreme. Birds, the direct descendants of dinosaurs, were among those who managed to survive the catastrophe. Not all birds, far from all. Only the small species survived, those able to feed on seeds and insects, able to hide in burrows and crevices, able to make do with minimal food in a world where food was almost non-existent. Mammals, destined to become the dominant animals on the planet, also survived. Small, rat-like creatures that had hidden in the shadows of giants throughout the Mesozoic era, hunting only at night, suddenly found themselves masters of a desolate world. The irony of fate. It was precisely their insignificance, their small size, their ability to burrow into the ground and feed on anything that turned out to be the key to their survival. The same qualities that made them invisible in the dinosaur world also saved them from extinction. Gradually, over hundreds of thousands and millions of years, life recovered. Forests grew anew. Oceans teemed with creatures once again. But the world never returned to what it was before the impact. The places occupied by dinosaurs were taken over by mammals. They grew in size, they filled empty ecological niches, they diversified into thousands of species. One line of mammals became primates. One line of primates descended from the trees to the ground. One line of these land-dwelling primates began to walk on two legs. One line of these bipeds began to make stone tools. And now, 66 million years after the impact, one of these creatures sits and reads a text about how the dinosaurs died. Without the asteroid, who knows what life on Earth would look like today? Without this sudden disruption of permanence, which completely transformed the planet and all life on it, we may never have had the chance to become what we are today. It's unclear how long the age of humanity will last. Modern humans have existed for only 0.1% of the time the dinosaurs did. And in that tiny span, we've accomplished something remarkable. We've conquered the world, entered space, and split the atom. However, our future and our long-term survival are not guaranteed. If we're not careful, it could all end in an instant, just as the age of dinosaurs did. But unlike them, we have one enormous advantage. We know that our permanence is fragile, even if it doesn't feel that way. We can look to the sky and track asteroids. We can plan for millennia ahead. We can be prepared, vigilant, and hopeful. And with luck, our journey will continue for a very, very long time.